Gladstone in central Queensland. Major industrial hub, gateway to the Great Barrier Reef. Its harbour of Port Curtis is being transformed by a massive dredging project.
Gladstone has been an industrial port for several decades now, and there's evidence from other ports in the world that marine life can get sick if the heavy metals and mud are stirred up from the seafloor of harbours like this. So here's the question. Could all the dredging that's going on here to expand the port cause disease in fish and crabs?
On one side of Port Curtis, a deeper channel is being dug for 6 new terminals to load giant ships with coal seam gas. The dredge mud is pumped behind a bund wall to reclaim more than 200 hectares of land for the Gladstone Ports Corporation. The rest of the mud is dumped outside the harbour into the Coral Sea. Fish veterinarian Dr. Matt Landos believes marine life is being contaminated.
We're moving the metals out of the sediments, into the food web, into the animals.
Dr. Leonie Anderson also trained as a veterinarian and runs the monitoring program for the Gladstone Ports Corporation.
All I can say from the results that we've taken that the dredging hasn't made a difference to the water quality in the harbour, apart from some elevated turbidity. And people have the misconception that turbidity is toxic, and it's not.
There are 2 sides to every story, so I'm boarding boats from opposite sides of the debate. We're heading past the bauxite refinery and the coal loaders into the industrial zone of Port Curtis. The turbidity here, that is, how muddy the water is, varies naturally between wet and dry seasons. But Matt worries all the man-made changes in the harbour are enough to put the fish off having sex.
It's really the equivalent to having your mother come in and turn the light on. You only get 1 shot at it for fish in the year. And if they lose that opportunity, we've lost a whole year class of fish.
At this time of year in Gladstone Harbour, it's winter, there's no rainfall, and the tides are really small. You'd expect the water to be really clear. In fact, normally, the visibility is about 3 metres. What's your visibility reading?
10 centimetres of visibility in the water.
10 centimetres. Is that normal for this time of year?
No, it's totally abnormal. So this has deteriorated even further from when we were doing sampling just 6 months ago, and now the dredging has escalated further.
This sort of dredge is considered quite a clean operation, so the material that it is dredging is actually being sucked up and taken to a reclamation area.
Nevertheless, satellite images show plumes of turbidity extend as far as 35 kilometres from the main dredging site. The long plumes can't be explained only by natural forces like tides or river discharge. On her boat, Leonie's job is to make sure the water quality meets Australian environmental standards. Her fleet maintains 18 automatic buoys that measure water chemistry every 15 minutes.
The breadth of parameters that we measure and the frequency of sampling and the extent of the sites that we cover is bigger than any monitoring project that I've heard of in Australia. It is quite extensive.
Downstream of the dredges, this boat carries an acoustic Doppler current profiler that bounces sonar off mud particles in the water column.
It sends a ping every so many minutes as they're motoring along at a slow pace. It's important to track dredge plumes and also to calculate the concentration of those plumes, and that helps us make sure that we're monitoring in the right locations.
While the mud particles are visible, the metals they carry are harder to find. After the dredging started, Leonie's team began monthly sampling for the metals that get dissolved.
They're the ones that are most important because they're the ones that are potentially bioavailable to the food chain.
There are few labs in Australia able to detect trace metals in marine waters. This is one of them, CSIRO at Lucas Heights in Sydney.
There's a whole suite of metals that we analyse for. Some of them include aluminium, cadmium, copper, cobalt, nickel, lead and zinc.
It doesn't take much dissolved metal to trigger effects in marine life. Measuring it needs sensitive techniques that can detect minute concentrations.
Parts per trillion.
Parts per trillion?
Yeah, we need to be able to measure down to that kind of range to be able to measure the real concentrations in the environment.
Since the dredging started in Port Curtis, CSIRO has sampled dissolved metals for 3 days and didn't find any contamination hotspots. However, they were able to compare their samples with what they collected nearly 10 years ago.
We saw a slight increase in dissolved copper and zinc concentrations in the harbour compared to back then. We found sort of detectable concentrations of aluminium in most locations across the harbour, which are above the environmental concern level that applies in Australia.
To know when metal levels become toxic, water quality standards set limits called trigger values.
The fact is that the dissolved metals haven't gone above those triggers, and those triggers are set based on a lot of science.
But not yet for aluminium. There's currently no water quality standard for aluminium in marine waters because the research is still being done. CSIRO is exposing algae to different levels of aluminium to discover how much is toxic.
Are algae often neglected?
They can be. They're not often seen, so it's important to look at them because they drive a lot of the processes that are going on with an ecosystem.
It's crucial to have reliable toxicity data because when algae die from metal poisoning, the whole food chain suffers.
Port Curtis is a beautiful estuary full of life. In fact, where I am right now is inside the Great Barrier Reef World Heritage Area. So you'd expect a place like this to support a productive fishery.
Can you tell what's going on the skin there?
And it did, until a year ago, when fishermen reported sick fish with cloudy eyes, rashes, eroded fins and sores. Fisheries Queensland banned all fishing in the harbour for 3 weeks and launched an investigation. 4 months after dredging commenced.
Well, there's an important thing in investigating an outbreak is you need to try and sample at the time of the outbreak.
So Matt started his own independent research, funded by donations from the public and the seafood industry, working with fishermen to try and figure out what was happening.
We had a look at the gills of the fish for damage to the gills. We then did a full necropsy on the animal, examining all of the internal organs.
Matt took bacterial swabs and organ samples from a number of species.
We identified skin disease in a whole range of fish. We also identified problems internally in the fish with parasites, what appears to be increased intensities of parasitic infection.
Bob Appo has seen this before. Over the 36 years he's been a crab fisherman here, the harbour has been dredged 3 times.
Every time it dredged, the fishing just went down. The prawns, the fish, the mud crabs, everything. I've gone from 150 kilos to about 50 kilos on a good day. And this is only just the start of it. There's another 3 years at least dredging to go on.
He's helping Matt investigate a disease in mud crabs called rust spot that ulcerates their shells.
That one actually has a rust spot on it.
Oh, yeah.
Are you right there,
Yeah,
Bob?
yeah, right, yeah. I'm watching me toes.
This little orange spot here is what is unique as a disease to the crabs in Gladstone Harbour. And that becomes a weak spot, and bacteria like to invade weak spots. When crabs get increased rates of exposure to metals like copper and zinc, their shell doesn't reform properly. And so after they've molted, they don't end up with a nice hard shell to protect themselves. They end up with these deformed shells. It progresses in many of the crabs to actually go right through the shell.
This disease was first studied by Leone back in 1998.
I don't think the prevalence of disease has changed at all since I last investigated. I think that people are just more observant and now seeing things that they might not have noticed before.
So looking at the bigger picture, do metals have anything to do with the shell disease?
I can't, we didn't find conclusively that that was the case.
Matt's theory is that the immune systems of harbour animals are being overwhelmed by multiple stresses like noise, turbidity and mixtures of heavy metals.
In this case, we should be looking at first at the animals. They're telling the story. If they're sick, there's something wrong with their environment.
Is it not conceivable that dredging could be one of the factors that are contributing to what people are seeing in the fish and crabs?
I just don't see that when, by default, by maintaining the water quality within Australian standards, we are maintaining ecological health. You wouldn't include fish disease monitoring in a standard dredge project, and particularly when you know your water quality is of a high standard, you're sort of going, well, you know, is there anything more we should do?
Solving the mystery of the disease means following the trail of dissolved metals to see how much ends up in the animals of Port Curtis.
Well, I think it's quite important to look at metal concentrations in fish tissues, and we've certainly recommended that as a follow-up to our study.
Has it been happening?
Not that I'm aware of, no.
Why is that?
I don't know. It's up to the regulators that look after the system to really prioritise the research studies that need to be done.
As the dredging continues, Queensland government agencies are yet to release all their results from the first 12 months of studies. But Bob Appo has had enough of catching fewer crabs that are too sick to sell.
Lucky I'm at the age where I can say, well, that's enough, but I still love it, that's the thing. It is heartbreaking that this has happened and I just don't even want to come near it.
Next time on Catalyst, a perfect record of Australia's dinosaur past, in danger of disappearing forever.